Potential difference incorporated. ReGenX generator and ReGenX quantum motor prototypes for performance testing and validation March 17, 2022. ReGenX generator prototype number 1. ReGenX prototype number 1 is a demonstration prototype whose primary function is to introduce the ReGenX generator's US patented load current delay feature, which is the primary contributing factor to the generator's ability to reverse generator armature reaction, aka AVL regenerative braking, and to produce AVL regenerative acceleration. Prototype number 1 consists of an E-core salient pole generator coil which incorporates two different coil types. The outer winding of the ReGenX E-coil is the conventional generator coil and the inner winding is the ReGenX generator coil. The conventional generator coil delivers electrical power to the load and it produces counter-electromagnetic torque, while the ReGenX generator coils provide the complementary electromagnetic torque in order to counteract the counter-torque produced by the conventional coil. Prototype number 1 is also designed to demonstrate that the ReGenX generator coil have the ability to deliver more electrical output power to the load over the conventional generator coil without requiring additional prime mover input power and without additional mechanical drive shaft input power over the load steady state speed rotational equilibrium requirement. Prototype number 1 and E-core ReGenX generator coil. ReGenX prototype number 1 dimensions and components: prime mover type, 1/3 horsepower. Induction motor prime mover voltage equal 120 volts. Prime mover current equal 1.5 amps. Rotor, permanent magnet rotor. Rotor masses: prime mover rotor plus permanent magnet rotor equal 3.2 kilograms. Rotor radius equal 0.1524 meters. Rated speed equal 3500 rpm. Drive shaft height equal 8 inches approximately. Drive shaft diameter equal 0.5 inch. Coil and core design: salient pole E-core with single conventional generator coil and dual ReGenX generator coils on the same E-core. Loads: 10 ohm AC light bulbs with power factor of 1. Generator output equal 10 watts AC, 10 volts, 1.0 amps. Desired testing procedure: 1. Bring system up to rotational equilibrium on no load and record prime mover input power consumption, drive shaft torque and speed. 2. Place conventional generator coil on load and record prime mover input power consumption increase, drive shaft torque increase and speed decrease. 3. Place ReGenX generator coil on load and record prime mover input power consumption decrease, drive shaft torque increase and speed increase. Observational expectations: conventional generator performance. 1. When the conventional generator coil is placed on load, the system speed will decrease to below that established at rotational equilibrium at idle because the electromagnetic fields created around the conventional generator coil produces a counter-electromagnetic torque and it decelerates, reduces the kinetic energy of the generator prime mover system. 1a. The kinetic energy of the system is decreased. 2. About 10 watts AC will be delivered to the load. 3. The induction motor prime mover input power consumption will increase automatically or will need to be increased manually in order to maintain the original no-load system speed at rotational equilibrium. 4. And the drive shaft mechanical power will need to be increased above 10 watts, above the electrical power delivered to the load. 5. The conventional generator coil's load current sine wave can be observed on the oscilloscope. ReGenX generator performance. 6. When the ReGenX generator coil is placed on load, the system speed will increase to above that established at rotational equilibrium at idle because the electromagnetic field created around the ReGenX generator coil produces a complementary electromagnetic torque and it accelerates, increases the kinetic energy of the generator prime mover system. 6b. The kinetic energy of the system will be increased. 7. About 11 watts AC will be delivered to the load. 8. The induction motor prime mover input power consumption will decrease automatically or will need to be decreased manually in order to maintain the original no-load system speed at rotational equilibrium. 9. And the drive shaft mechanical power will need to be decreased to below that which was established at rotational equilibrium at idle on no load. 10. The ReGenX generator coil's load current sine wave can be observed on the oscilloscope with about a 50-degree load current time delay. Special note: Electromagnetic field energy flux harvesting 11. When the ReGenX generator coil is placed on load, it will be mathematically observed that the output power delivered to the load from the conventional generator coil will increase instantaneously before the system speed has had a chance to increase, i.e. before the rate change of magnetic flux in the coil increases with increased frequency. Note, prototype number 1 employs, 1. A conventional generator coil to provide electrical power to the load 2, and the ReGenX generator coils to provide a complementary electromagnetic torque to the system in order to override the conventional generator coil's counter-electromagnetic torque. 14. This means that the electromagnetic field created around the ReGenX generator coil, S, which are wound on the middle core finger of the E core, is being collected into the core of the conventional generator coil, which is wound on the outer core fingers of the E core. 15. The ReGenX generator coil's electromagnetic fields perform two different forms of work: 1. Electromechanical, accelerating or performing positive work on the generator's rotating magnetic field, and 2. Electrical, increasing the magnitude of the magnetic flux, rotor flux plus electromagnetic flux, inside the conventional generator coil, and thereby increasing the generator's output power delivered to the load. 16. Load current sine waves for conventional generator coil and ReGenX generator coil in prototype number 1 measured across identical purely resistive loads. Conventional coil load current sine wave green. ReGenX coil load current sine wave purple. Top dead center rotor magnet neither approaching nor receding. Load current sine waves for conventional and ReGenX generator coils. Conventional coil time delay equals 0. Work performed by photon energy is negative work, system kinetic energy decreases. ReGenX generator coil time delay equals 50 degrees. Work performed by photon energy equals positive work, system kinetic energy increase. Energy source in both cases is created subatomic quantum photon energy. Detailed description of time-delayed field production in the ReGenX e-coil. How two types of work is performed in prototype number 1. Negative electromechanical work performed by a conventional generator coil according to Lenz's law of induction. When a north pole magnet approaches a generator coil and current flows in the coil, a north pole electromagnetic field will be created around the coil which will resist the magnet's approach. And when the north pole magnet moves away from the coil, a south pole electromagnetic field will be created which will resist the magnet's departure away from the coil. Rotor flux direction and induced field electromagnetic flux in the ReGenX e-coil. The ReGenX e-coil is designed so that the complementary electromagnetic torque magnitude produced by the ReGenX generator coil is greater in magnitude than the counter-electromagnetic torque magnitude produced by the conventional generator coil, so that the net effect is system acceleration and kinetic energy increase. Positive electromagnetic field energy harvesting. Flux harvesting. How ReGenX coil flux harvesting occurs in the conventional generator coil. According to Lenz's law of induction, the conventional generator coil will be creating a south pole resisting electromagnetic field when the north pole magnet is moving away from it. The ReGenX generator coil is creating a south pole electromagnetic field, while the conventional coil's core flux direction is also a south pole direction, and the two identical fluxes sum together and increase the conventional generator coil's electric power delivered to the load. While at the same time the ReGenX coil is also producing south pole electromagnetic field energy which performs positive work accelerating the south pole rotor magnet's departure away from the ReGenX coil, while simultaneously attracting the north pole rotor magnet which is approaching the ReGenX generator coil. Prototype number 1 schematic diagram. Prototype number 1 Waddy's generator armature reaction, AVL regenerative braking, and AVL regenerative acceleration, video demonstration.
So I'll put the conventional generator coil on load right now. Okay, so I've placed the conventional generator coil on load, we can see that the load current is 0.88 amps. There we go. Okay, I'm going to put it on to no load again. So on no load at equilibrium, our system speed is 3,458 RPM. The input current or the input power to the prime mover is 144 watts. When we place the conventional coil on load and we deliver approximately 10 watts to the load. Disappear. When we deliver approximately 10 watts to the load, the prime mover responds by consuming an additional almost an additional 20 watts. And the system decelerates. I'm going to put it on to no load again, and then I'll put it on load. So here we are at no load again, steady state speed, equilibrium. Prime mover is delivering 145 watts. The prime mover is consuming 145 watts, and at equilibrium, the net power in the drive shaft is 0. Placed on load, the prime mover responds, the counter torque produced by the generator decelerates the system, the prime mover responds by consuming more power. We're delivering 0.87 amps to the load, and we can see the load current sine wave for the conventional coil on the oscilloscope. So now I'm going to put the ReGenX generator coil on load. So now the ReGenX generator coil is on load. We are in regenerative acceleration mode. We are delivering 0.92 amps to the load. Our system speed is 3,464 RPM, 64, and our input to our prime mover is 140 watts. The input to the prime mover is consuming less power and delivering less mechanical power in the drive shaft than when the system is on no load. So I'm going to put it back into regenerative braking mode again, and you can see in green the load current sine wave for the conventional coil, and then the load current sine wave for the ReGenX coil, which is delayed by approximately 50 degrees. So back into regenerative braking mode. So now, if this was in an electric vehicle, the vehicle would be in regenerative braking mode and delivering power to the batteries and decelerating the vehicle. And now I'm going to place the generator into regenerative acceleration mode. Now the generator in the electric vehicle is in regenerative acceleration mode. The speed of the EV has increased. The output current, the recharge current, the regenerative acceleration current going to the EV's batteries has increased, and the prime mover, or the EV's motor, is using less power than when on no load. And I'm going to place, I'm going to shift the ReGenX generator coils load current to basically 90 degrees. So now we have increased the load current delay in the ReGenX generator coil to 90 degrees. The input to the prime mover has gone down even more. The load current has increased slightly, and the speed has also increased slightly. So the ReGenX generator coils load current delay needs to be minimally 45 to 50 degrees to induce regenerative acceleration, but it can also go to 90 degrees as well if that's desired. And that's the end of part 2. ReGenX motor is coming up next.
ReGenX generator and ReGenX quantum motor prototype number 2. ReGenX generator prototype number 2 consists of 1 conventional generator coil, yellow, and 3 ReGenX generator coils, green, red and blue. Prototype number 2 consists of 4 C-core salient pole generator coils. 3.5 amp commercially manufactured C-core ReGenX coil, 60 amp ReGenX generator coil. ReGenX prototype number 2 dimensions and components. Prime mover type, 1 horsepower induction motor. Prime mover voltage equal 120 volts. Prime mover current equal 5 amps. Rotor, permanent magnet rotor. Rotor masses: prime mover rotor plus PM rotor equal 5.7 kg, rotor radius equal 0.31 meters. Drive shaft height equal 8 inches approximately. Drive shaft diameter equal 0.75 inches. Rated speed equal 3500 RPM. Coil and core design: salient pole C-core with conventional generator coil and 3 ReGenX generator coils. Loads: 12-volt battery generator output equal 90 watts DC, 10 volts, 1.0 amps. Desired testing procedure: 4 bring system up to rotational equilibrium on no load and record prime mover input power consumption, drive shaft torque and speed. 5. Place conventional generator coil on load and record prime mover input power consumption increase, drive shaft torque increase and speed decrease. 6. Place ReGenX generator coils on load and record prime mover input power consumption decrease, drive shaft torque increase and speed increase. Observational expectations, conventional generator performance 17, when the conventional generator coil is placed on load, the system speed will decrease to below that established at rotational equilibrium at idle because the electromagnetic fields created around the conventional generator coil produces a counter-electromagnetic torque and it reduces the kinetic energy of the generator prime mover system. 17a, the kinetic energy of the system will decrease. 18, about 60 watts AC will be delivered to the load. 19, the induction motor prime mover input power consumption will increase or will need to be increased manually in order to maintain the original no-load system speed at rotational equilibrium. 20, and the drive shaft mechanical power will need to be increased above 60 watts, above the electrical power delivered to the load. ReGenX generator performance 21, when the ReGenX generator coil is placed on load, the system speed will increase to above that established at rotational equilibrium at idle. 21a, the kinetic energy of the system will be increased. 22, about 90 watts DC will be delivered to the load. 23, the induction motor prime mover input power consumption will decrease or will need to be decreased manually in order to maintain the original no-load system speed at rotational equilibrium. 24, and the drive shaft mechanical power will need to be decreased to below that which was established at rotational equilibrium at idle on no load. 25, Table 1.0 demonstrates that ReGenX prototype number 1 delivers 90.2 watts to the load while the kinetic energy of the generator prime mover system increases by 70 joules. 26, no additional input energy is supplied to the prime mover and no additional mechanical drive shaft power is supplied to the ReGenX generator. 27, the ReGenX generator coils deliver 90.2 watts of electrical output power to the load. 28, the kinetic energy of the system is increased by 70 joules. Prototype number 2 ReGenX EV quantum motor introduction. ReGenX quantum motor performance 29, when the ReGenX quantum motor is placed on load, the system speed and drive shaft torque will increase to above that magnitude which was established at rotational equilibrium at idle. 30, no additional input energy is supplied to the prime mover and or the ReGenX quantum motor coils and no additional mechanical drive shaft power is supplied to the ReGenX quantum motor. 31, the kinetic energy of the system will be increased by 153 joules. ReGenX generator performance when operated below the coil's critical minimum frequency 32, when the ReGenX generator coil is operated below the coil's critical minimum frequency and when it is placed on load, the system speed will decrease to below that established at rotational equilibrium at idle. 32a, the kinetic energy of the system will be decreased. 33, 0.00 watts DC will be delivered to the load and the system will stall. ReGenX EV regenerative acceleration generator prototype number 3. Electric vehicle regenerative acceleration innovation introduction video, potential plus/minus difference incorporated. We generate solutions.
system speed is 3,536 RPM. Our bike motor current consumption is about 5 amps. And our ReGenX battery voltage is 74.9 and going down. So now I'll put it into regenerative acceleration mode. Acceleration mode. We're delivering 5.34 amps to our batteries. Our system speed has increased slightly in regenerative acceleration mode, and our bike battery voltage is increasing. Put it back into normal motor mode without the ReGenX innovation engaged. So as you can see, the battery voltage is going down. Now I'll put it into regenerative acceleration mode again. .3 amps of regenerative acceleration current going to the EV's batteries is enough to maintain the e-bike's battery voltage . 75.1. I'm just waiting to see if it's going up or down. So as you can see, the battery voltage on the e-bike is not changing. With the ReGenX generator in an electric vehicle, the battery voltage will not go down, and as a result, the EV battery voltage will not decrease, and the EV will not require plug-in charging, while the EV has essentially unlimited range. battery voltage is 74 volts, or to be more precise, 73.2 volts. So we want to look at what is our battery voltage after we're done the test. So I'm just moving the camera back so that I can start the system, and then I'll move everything back in. So the e-bike has cruise control, so once the speed is set, then it's pretty much fixed.